Thank you, Richard. Good morning, everyone. Now, it's a welcome opportunity to stand before you all, both here and online, to present on the supplementary documents that have been published by the department in the last couple of years. It's often important to, I suppose, revise and revisit the guidance of the documents that do exist that can support compliance in construction. I don't know if it is as a result of the CPD seminar or other factors at play, but we have seen an increase in interest in queries in respect of the supplementary guidance documents in the past couple of weeks. It shows that they're being read, they're being scrutinized, and hopefully through this morning's lecture presentation, we can, I suppose, get to grips with some of the more pertinent details of the documents. So, as I said, we have been busy publishing these documents with the end objective of supporting construction or compliance in construction to ensure that the buildings, when completed, comply with the building regulations. And my focus this morning is on our domestic dwellings, and I think I couldn't make any better emphasis than Chief Officer Carroll made. These are our homes where people live. They, when they're completed, they should be completed to a satisfactory capacity that they are safe and fit for purpose for people to live in. The supplementary guidance document was published with that in mind, that it would bring forward constructional details that were proven under robust test to meet the requirements of the building regulations. To clarify the matters of the build-ups of walls, floors, and trussed roofs, to provide information to designers, to assign certifiers, to builders, to local authority inspectors, to those who are bringing materials, putting materials together on site. I'll also be speaking to the Loft conversion guidelines, which were published earlier this year. Thankfully, there haven't been too many comments or observations or questions to the department in that respect. So I presume that everyone is very happy, and the document is well received in the built environment. Before we get into the technical provisions of the supplementary guidance, it's no harm to look at the status of the guidance in the regulatory environment in which we operate. So it all starts from the Building Control Act 1990, number 3 of 1990, which provides the overarching, I suppose, requirement set out through the Oireachtas that buildings are built with the safety, health and safety of people in mind in their delivery. Section 3 of the Act is most relevant in this case, that the Minister can make building regulations, the Minister can publish documents to support those regulations. Through Section 3, we have SI 497, amended quite a number of times since its publication in 1997, but giving the provisions of the building regulations that we know and apply to our buildings. They are being continuously updated. The most recent was only a number of weeks ago in respect of Part L, with a Part M public consultation having concluded on the provisions being finalised. But through SI 497, we have the functional requirements of the building regulations, the legal statements of compliance that all buildings must meet, set out in the second schedule. We have the works types to which the building regulations must conform, set out through Articles 10 through to 13, for new buildings, for material alterations, for extensions, material changes of use. We do also, and sometimes forgotten, have the overarching requirement set out in Article 9. First and foremost, that buildings comply with the building regulations, that in compliance with one regulation, no other regulation is diminished. And most, I suppose, particular to existing buildings, to material alterations and changes of use, but there's no new or greater contravention. But in carrying out works, you don't make the building worse. Article 7 of the building regulations gives the power to make technical guidance documents to fulfill the requirements of the functional requirements. And in that respect, we have the technical guidance documents. Again, speaking most particularly to Technical Guidance Document B, Volume 2, 2017 for dwelling houses. But each of them is designed to operate as the sequence or the set of documents delivering compliance with the building regulations. We don't build walls or floors or elements just for fire. They have to conform to many requirements of the building regulations, structure and energy, resistance to moisture, and other matters set out in the building regs. And finally, we come to the particular documents published under TGDB 2017. Supplementary guidance, again, as I said, was designed to support particular provisions of the Building Regulations 2017 for dwelling houses, to provide specific build-ups for timber constructions, walls, floors, and trussed roofs, to meet the requirements as set out in the building regulations. The supplementary guidance, the particulars of it, it's our way to comply with the requirements. We still have the functional objectives, we still have the performance objectives set out in the TGD, but the particular drawings and the details are a proven way to comply with the requirements. The loft conversion guidelines are published under Appendix D of TGDB 2017, replacing an earlier document, and are again a simple and straightforward approach to converting unused or spaces to free up space in dwellings. Before we get into the supplementary guidance, it's important to note some of the subtle variations between the predecessor to TGDB 2017 and the current document. So in 2015, a decision was made to split the technical guidance document into two specific volumes, one for dwelling houses and one for buildings other than dwelling houses. In publishing TGB 2017, account was made in respect of not only the functional requirements, but the holistic regulatory environment in which it operates. So it was set out, and again, the main driver behind the building regulations and the provisions of the TGD is the text in grey, the text set out in the second schedule, that a dwelling house is designed so that in the event of a fire, its stability is maintained for a reasonable period of time as a legal obligation. That a wall common to two buildings offers adequate resistance to the fire spread between buildings. And a dwelling in itself, in the contiguous dwelling, in the unit, it's subdivided as necessary to restrict fire spread through the dwelling, but in a manner that's reasonable in respect of the building. And that the dwelling itself is designed so that the fire spread in hidden spaces is restricted where it's deemed necessary. In achieving these functional requirements, we have the specific prescriptive provisions of the TGD. For our fire tests and for our build-ups meeting a performance requirement, the text of Appendix A, Table A1 is most relevant. And here's where the variations, I suppose, come into between the 2006 and 2017 documents. That for buildings built in accordance with the Eurocodes, the performance specified must be achieved when tested in accordance with the European test methods. So all buildings built under TGDA are built in accordance with the Eurocodes. So it stands to reason that the structural elements that have to have a fire resistance would also be tested in accordance with the European test method. In order to claim a specific resistance for load-bearing construction, it must be tested to ISEN 1365 in support of those objectives. So that wall build-ups must be tested having regard to their end intended use, having regard to the specific build-ups that are to be applied on site. For the given test, for the given building elements, there are various variations in the performance requirements. For a two-story dwelling house, we have a performance requirement of the intermediate floor of what's termed as an R30 REI 15, or sometimes called the modified half-hour requirement. For other floors in the dwelling, it's a full 30 minutes REI. For external walls, the performance requirements are dependent on the distance to the boundary of the site, whether it's less than a metre from the boundary at 30, 30, 30, or more than a metre from the boundary 30, 30, 15 when tested from the inside. The separation wall of the building has to achieve a nominal 60 minutes or better. in accordance with the requirements. Protected stairway enclosures have to have a 30-30-30 requirement, depending on their end use, whether the walls forming the enclosures of the stairway are load bearing or not load bearing. And finally, roofs in specific circumstances are required to have a fire resistance, so most particularly where the roofs form part of an escape route, but there are other circumstances, and those details are again set out in the supplementary guidance. Moving on to the sub-guidance document in detail. This document, I suppose its existence is as a result of the detailed, I suppose, application of the fire resisting and fire test requirements carried out by the timber industry in Ireland. That fire tests, robust destructive tests, were carried out on a number of wall, floor and truss roof build-ups to EN 1365 by the likes of the Irish Timber Frame Manufacturers Association, Truss Rafters Association and the Structural Timber Association. There were industry tests carried out on industry build-ups that were reflective of what was built in the built environment at the time. So they are absolutely reflective of what we would expect to find on a site using materials we would expect to find on a site. As with any testing system or test of any system, there can be, I suppose, variations to the particulars of the test, but within approved rules. For example, and it is set out in the supplementary guidance as a means to, I suppose, highlight what can and can't be done within the parameters of the test. For example, a type F plasterboard giving a higher performance than a type A can replace a type A, provided that it doesn't reduce the thickness of the board, except where it's specified. And there's one example in the sub-guidance where a 15 type A can be replaced by a 12.5 type F board. And the reason we can say that is because it was tested, it passed the test and it achieved the requirements. A reduction in thickness of the plasterboard were not specified, or a replacement of boards that are not plasterboard to EN 520, it doesn't fall under the sub-guidance and would need their own distinct tests and proofs to an equivalent performance and performance of the elements in use, having regard to their end construction makeup to their end use. Ultimately, the build-up, the fire-resisting wall, floor, truss, is a result of the combination of the design, the materials used in their particular configurations, whether it's trusses, noggins, linings, etc., the thicknesses, the spacings of the materials, and the build-up together with the workmanship employed on site during the assembly of the components. Again, they're not a mandatory requirement, but they're simple, straightforward means to comply. And if the details don't comply with the requirements, well, then questions will be asked of the build-ups. What tests prove the elements? What tests prove the build-up in respect of the particular details? The first series of tests that were carried out were in respect of external walls, timber frame external walls built to similar configurations that will be found in the current standard IS 440 for timber frame construction. Wall of these types, they do have a fire performance. They have to have they have a load bearing capacity carrying the load of the building. But a wall is not just a wall for the purpose of resisting fire. It's also a wall for the purpose of transferring the load to the foundations. It has a requirement in respect of air tightness, in respect of energy. The wall must achieve a U value. So when the tests were done, they were all done with all of these matters in mind, and they were reflective of the end use product that would be applied and built on the site. The tests that are represented in the supplementary guidance are the ones that passed and robustly passed the tests. There were a fair few tests that didn't pass the requirements, and for obvious reasons couldn't be included in the tests, but these represent those build-ups that through the destructive testing did meet the requirements. The studs in the walls were 89 and 138 millimeter studs, again reflective of the build-ups and the types to be used in the built environment. Constructions, each of the studs was appropriately loaded, having regard to the axial loads would be specified and required under the Eurocodes for a dwelling house or a typical dwelling house construction. In use of the build-ups, the thickness of the structural elements can be increased. So again, working to within the field of operation of the fire test, that those studs forming part of the structure can be increased, but not decreased. Again, tests were carried out on the minimum stud thicknesses. So it does stand to reason they can be modified, but only as long as it increases the stud thickness. The insulation between the studs can vary. Again, the insulation carries a part L function in respect of the building, meeting the requirements of meeting the provisions set out in TGDL. But of course, if the insulation thickness varies from that provided, then U-value calculations would have to be carried out on the walls. These walls did conform to the U-value requirements. The insulation on the face of the studs, as is denoted in two of the diagrams, in wall type 1 and wall type 4. This one here showing that's a PIR insulation on the face of the studs. It was tested up to a maximum thickness of 50 millimeters. So the thickness of the insulation can be reduced, but not increased beyond the 50 mil, as again, it wasn't tested beyond 50 millimeters. Each of the walls, the external walls, are tested with an industry standard socket box set in the walls without fire stopping, and it passed the tests. So these elements have been robustly tested with having regard to their end intended use and to their actual practical, reasonable application on the construction site. The separating wall, it may look familiar in terms of various publications under the technical guidance documents. Looks very similar to that of the ACDs for timber frame construction for the robust details under TGDE, because they're all the same wall. They all have to achieve a multitude of requirements through the same build-up. So again, it stood to reason that the tests will be reflective of the end-use product achieving all of those requirements when tested. So for that reason, there's still is the insulation that is provided, the double boarding on the SEP wall, the VCL, breather membrane, OSB racking board were all provided in the tests to reflect that which would be built on site. A series of floor types were tested, 3 distinct floor build-ups: solid joist, metal web joist, and I-joists. Again, it's useful to reflect what the performance requirements set out in the building regulations in respect of an intermediate floor in a dwelling. For a typical 2-story dwelling, a 30-15-15 performance is permitted under the TGD. That is a load-bearing capacity of 30 minutes and integrity and insulation of 15. Each of these build-ups did robustly pass those tests. In fact, in the case of the timber build-up, it went well beyond the testing timeframes. It was it did exceed the testing the 30 minutes by quite a good amount. Each of the constructions was fully loaded to 1.5 kilonewtons per meter squared, again reflecting the requirements set out in the Eurocodes through TGDA in respect of the loads in respect to the building. A particular emphasis has to be placed on the what's termed as the engineer joists, the metal web and the I-joists. Each of these elements brought to the testing facility and tested did have an ETA for the specific joist. So there is a European technical assessment for the system or for the product in use. There's obviously the solid joists are covered under standards, but those systems, those elements, only comply on site when put together with other elements that have been tested in a robust manner to meet the requirements. So it's not any ETA with any set of build-ups, it's specific products that have been tested in their end-use configuration. With the engineered joist, there's an open void in between the joists that doesn't exist with a solid joist floor where the plasterboard is directly fixed to the soffit of the joists. So any fire or smoke that gets into, or hot gases that get into the void in an engineered joist can spread rapidly throughout the entire void space. And for that reason, there's a specific obligation set out under the SUP guidance that any service penetrations into such a build-up, into the engineered joist build-up, must be fire stopped to inhibit the spread of smoke and hot gases into the void space. Again, it's the premature collapse of the elements before the 30 minutes that drives the requirements. The floors still have to remain in situ for the full 30 minutes, and the smoke and hot gases getting in may have an impact on that performance. The same can be said for counterbattens beneath a solid joist floor. If you counterbatten beneath the floor, it again opens up lateral movement of smoke and hot gases. So for that reason, where there are counterbattens beneath a solid joist floor, it's treated like an engineered joist floor, and again, surface penetrations through the floor, whichever the surface penetrations, downlighters, hoods, vents, etc., must be fire stopped. In respect to the build-up, all of the floor, the room edges were supported by battens. All of the decks tested were tongue and groove decks. So every single test included a T&G deck build-up. Again, a butt-ended joist or a butt-ended decking material can be used, but they have to be supported by noggins at the board edges, to support the board edges and to prevent or to support the fire resistance requirements at the butt end joists of the boards. In certain build-ups, on certain floors and trussed roof build-ups, stud walls can carry a load-bearing function, especially where there are extensive spans of the floor joists. To that end, again, certain stud build-ups were tested with the full appropriate loads to support the load of the building, of the floor, transferring through to the foundations. So details were given in the sub-guidance for both load-bearing studs, whether parallel or perpendicular to the joists, and for non-load-bearing studs, again, with a view to improving and aiding compliance on site. The non-load-bearing studs typically be used perhaps to enclose a room or close a stair with a fire-resisting function, but where it's not actually transmitting a load in terms of the structure. There were a series of truss tests carried out to, I suppose, to demonstrate compliance where there's a fire resistance requirement in respect of a roof buildup. Typically, there are three scenarios where a roof or ceiling would require a fire resistance. The first is in a dwelling of 3 or more stories, which requires a protected stairway. The provisions of TGDB 2017 require that the stairway is carried either to a fire-resisting ceiling, and the fire-resisting ceiling extending throughout the story, or the ceiling is not fire-resisting and a cavity barrier is provided in the attic. In the case of a trussed roof, however, as the trusses are a composite element, a failure in one part may cause premature failure across the entire trussed element and could have an impact on the cavity barrier itself and its performance before the 30 minutes, especially if there's a fire in an upper story room breaking in through into the attic space through unprotected elements. So for that reason, where it is a trussed roof in a 3 or more story building, the fire resistance is from the soffit, from the ceiling side. In the case of a dormer truss, the truss itself forms the function of floors, walls, and the roofing elements. And as it is again a composite construction, all the elements must be protected in order to give the adequate protection to the entire buildup. And finally, there are the circumstances where a roof forms part of an escape route from a dwelling, so whether a flat or a pitched roof or a roof with a slope. If it is set outside of a window and that doesn't give the provision for ladders to be placed against the windows, that roof can form part of an escape route. And there will be other circumstances where roofs may have to have such a fire resistant function as part of the escape from the upper floors of a dwelling. And again, in those circumstances, the roof should be fire resisting. The truss roofs, again, were tested to EN 1365 with an appropriate load applied to demonstrate the stresses that were provided by the tiling, by the wind snow loads on the build-ups. These were quite unusual and innovative in that it hadn't been tested before, not in a meaningful and a detailed sense. So there were full truss build-ups created in the testing laboratories with the appropriate loads provided to simulate the loads that we placed on a roof buildup. There are 2 particular types in terms of the attic trusses. There is the 47 and the 35 mil trusses. The 47 have details for direct fix of the plasterboard to the soffit of the joist with counterbattens to support the board edges. There are also details for a sacrificial layer, a service layer in respect of the 47mm joist. That service layer can be useful for the long-term use and operation of a dwelling, as any service penetrations to the attic must be fire stopped. And again, being back to this no newer greater contravention and not taking actions that would, I suppose, damage the fire resisting barriers to the building. The provision of a sacrificial layer, the service void, allows the fire line, the fire barrier, to remain intact while allowing services to be run inside of it. In terms of the 35mm truss, the trusses were set at 600mm centres, but there were counterbattens and noggins set beneath it at 400mm centres to adequately support the boards. Again, each of the build-ups passed the 30-minute tests. For the purpose of the sub-guidance, they were also shown not only with timber external walls, but with masonry external walls and specifications given in the sub-guidance for masonry build-ups. Each of the floor elements were tested both with hangers and with being fitted through to studs. For the dormer truss build-up, again, as I said, the build-up is a function of all of the elements, from the soffit, from the ground floor room or the lower space, providing protection to the board build-up, from the stub wall or the knee wall in respect of the dormer space, and the slope and horizontal roof elements. All the service penetrations into the dormer truss or the dormer roof build-up must be fire stopped again, except there's one except of a socket box in the stub wall or the vertical wall elements of a dormer room. And the wall build-ups were reflective of an external wall build-up, and as they were tested with socket boxes in place, it is again appropriate that boxes can be provided within the build-up. Again, where there's a stud wall in the lower level supporting the roof, it must also be designed as a load-bearing stud, and the provisions are given in the supplementary guidance in respect of load-bearing stud walls inside in the dwelling. Finally, as part of the supplementary guidance, fixing details were provided, again to provide clarity to support to ensure compliance on site, that specific details in relation to screw lengths having regard to particular build-ups, their centres and their provisions, the wall types through which they're being fitted to the studs, were detailed within the supplementary guidance. Moving on to the loft conversion guidelines. These guidelines were printed in 2022 and replace a 2004 loft conversion leaflet. It was updated in 2006 to reflect the then technical guidance document B 2006. They identify in detail a simple and straightforward approach to converting roof space in an existing two-storey building to facilitate unlocking unused space in our dwellings that don't require extensions into gardens, or where there may be limited space, or where there's additional needs of a family living in a dwelling house that they want to use these spaces. That it does specify or give guidance as to the appropriate provisions that have to be met in converting those roof spaces, but in an easy to understand, simple and straightforward approach. They're specified under Para 1365 and Appendix D to Technical Guidance Document B 2017. In carrying out a loft conversion, while the guidelines are published as an appendix to TGDB, or cited in appendix to TGDB, and it publishes supplementary guidance to it, the works have to conform to all the requirements of the building regulations. So in converting a loft, there's still a conversion of a non-habitable space to a habitable space, which would create a load and have a requirement in respect of structure in the dwelling. Materials have to be used and applied in respect of the dwelling. Those materials have to be proper materials under TGDD, for which the provisions are set out, that they have to have a standard or an Agrimo cert or an ETA, or be a part of a harmonized product, a CE marked product. Typically, new stairs are installed as part of a loft conversion. Thus, new stairways have to conform to the provisions of TGDK as they're a new element within the building. And other interventions are carried out in respect of the loft space. It might mean moving insulation from the horizontal to the slope of the roofs. Might be there's requirements in respect of ventilation of the building, of the provision of breather membranes, etc. So they do have to conform to the requirements of the building regulations. And again, back to the overarching requirement: don't make the building worse. To this end, it's often useful to, in terms of the design of it, to seek advice before the build-up to ensure that the entire composite construction at the end, when completed, does meet the requirements. There are a number of works and scenarios which may result, or I suppose we called it a question in the development of a loft conversion. The single-story building converted to a two-story building to a three-story. While not specified directly in the TGD, there can be other scenarios where taller buildings can have loft conversions. In respect of a single-story building converted to a two-story, the provisions of Para 132 are appropriate. The stair can rise through an enclosed stairway or can constructed within an enclosed stairway, but the provisions of 132 also apply where an open stair can be provided as long as windows for escape and rescue are provided from all the habitable rooms and the area beneath the windows is sufficient fit for purpose for self-evacuation. Slightly more complicated is the 2 to 3 story construction, as we're now converting a 2-story dwelling, which has the performance requirements of the modified half hour, etc., to a 3-story. They have to meet, once they can become a 3-story building, again, they can't contravene the building regulations or can't make it worse. The structural requirements apply, the requirements for a protected stairway apply. However, and this is where the loft conversion guidelines are so useful, there are circumstances where the modified half hour floors are appropriate as long as they fall within the characteristics of the loft conversion guidelines. That's no more than two habitable rooms at the upper level and no more than 50 square meters. In other buildings, would seem prudent that Para 134 would apply in respect of those taller conversions, but not without their own complexities, that any building with more than one floor, more than 4.5 meters above ground level, needs dedicated protected stairs and alternate stairs for escape. While it can be done, it's not conducive to reuse of buildings. Okay. Must have been something wrong with the conversion to the software. That was supposed to be a red box around the outline of the box. So what we're concentrating on is the loft conversion guidelines in respect of the 2 to 3 story conversion. So first and foremost, in terms of walls, again, this may have been or would have been a 2-story dwelling, being converted to 3 stories, may have had an open rising stair from the ground to the first floor, as was permitted under the current TGDB and its predecessors. In the case where it is converted to a 3-story, that stair has to be enclosed in fire-resistant construction to 30 minutes. The details, again, the supplementary guidance can be used in this effect, but also existing stud partitions can fulfill that function as long as there are 12.5 mil plasterboard and any service penetrations, socket boxes, light switches, etc., are fire stopped. In the construction of the new stairs, from the first to the second floor, there are two, I suppose, options given, or two scenarios given in sub guidance. One where the stairs rises above the existing stair, provided that it doesn't contravene or make the existing stairway worse or less safe for the navigation or for users using the lower stairs. However, there are circumstances where space doesn't permit the stairs to be constructed in the existing stair void or stairwell. And so a provision was given in the original loft conversion guidelines where a stair could rise in an existing room and have either doors at the bottom or the top. And an opportunity was taken in publishing the 2022 guidelines to supplement and clarify these provisions by means of additional drawings to show what the meaning and intent. That either the stairs is open at the bottom with doors provided at the top, the stairway enclosure is still a 30-minute enclosure to the underside of the roof, and given it's a loft conversion, it's reasonable to assume that it would be near enough to the soffit of the roof construction itself. with no more than 2 rooms per the SUP guidance. The other option is that the stairway being constructed in an existing room would have a door at the bottom. In this case, the stair and the habitable space are considered all as one space. So there's no requirement to enclose the stairs above the second floor level, just to have the stairway enclosure to be fire resisting as you descend down towards it, to protect the occupants from the adjoining room spaces. In this case, however, there can be an open void adjoining the stairs in certain circumstances, so they would have to be protected against falling under the provisions of Part K and TGDK. In addition, when a loft conversion is being carried out, it's an opportune time to look at the separating wall between the dwellings and to make good the separation wall to ensure that it is a full 60 minutes is carried to the underside of the roof and fire stopped in respect of the restriction of fire spread between dwellings. Floors in dwellings. Again, given it's a 2 to 3 story conversion, there would be an existing floor which have a requirement of 30-15-15. Ordinarily, a 3-story building or building higher than 2 stories in the dwelling house requires a full 30 minutes. However, in the case of the limited space conversion of the as set out in the loft conversion guidelines, no more than 50 square meters, no more than 2 habitable rooms, modified half hour is appropriate. An existing floor build-up at the new second floor level of 12.5 mil plasterboard on 37 mil joists with an 18 millimeter deck board should achieve that requirement of the modified half hour. It's important to note, however, again, as the requirement of the floor extends to the entire floor, the surface decking must extend to the inside face of the outermost walls, as it is the entire floor build-up that is meeting the requirements, not just the part of the floor that is forming the habitable area. So irrespective of the provision of the 50 square meter habitable area, there might be void spaces near to the eaves. Still, the entire decking element must extend wall to wall. As I said, for good, safe access and to an egress from the second floor, a new stairway is required from the second floor level. There are provisions given in TGDK where the stairs can be a spiral stairs or can be an alternate tread stairs, but there must only be 1 habitable room at the upper level, which is infrequently used. Obviously, the standard stairs at the appropriate rise and going would be more appropriate to give access to the provisions. But there are variations where are permitted where there is limited space, and it's proven that there is limited space within the building. In the conversion, the headroom for the new stairs can be 1.9 meters instead of the 2.0 or 1.8 where there's minor projections from the stairs. And again, for the existing stairs, and it leads back to that Article 9 provision, no near greater contravention, and the existing stairs should not compromise the safe passage of users for the occupants of the building. As with any of the building regulations, there's always the duty of care in terms of any designer, specifier, builder to ensure the safety of the occupants. Any doors of the stairway enclosure are required to be 20-minute E20 or FD20 fire doors, as for any 3-story dwelling. Windows to the stairway enclosure, with the exception of external stairways, have to be fire resisting and fixed shut. That is both windows that would be in the wall build-up and in any doorway. In addition to the windows protecting the stair enclosure from fire in the adjoining habitable spaces, the new loft areas also require windows for escape purposes. So these can be dormer or roof lights windows, meeting the requirements set out in the TGD, that they are 0.45 by 0.45 with a clear opening area of 0.33. And this, for the windows, detail and diligence should be paid to the opening section and the hinge point of the windows to ensure you actually achieve the clear openable area. Distance off the floor is again to be met in respect of a dormer window, 0.8 to 1.1 off the floor. There are again benefits to that in prevention of falling through the window space under TGDK and Part K. The slope on the roof measured from a dormer or from a roof light is to be 1.7 meters again to the eaves, and sometimes forgotten but no less important, the ground beneath that space must be fit for purpose for ladder access. When converting an upper level, we are in fact adding additional story to the dwelling, so it's prudent and necessary that the fire alarm system would be improved in the dwelling house, that where a dwelling may have had a small number of smoke detectors in the circulation spaces, so the requirements that would meet the current grade D LD2 requirements set out in the TGD, with detectors in the escape route spaces, in bedrooms and in high risk areas, kitchen, living room, utility room, garages, etc. throughout the building. I suppose in closing, the supplementary guidance document and the loft conversion guidelines were published to provide clarity, to provide a simple, straightforward approach to compliance to meet the requirements of the building regulations, to bring forward issues that might be found on the site and find an easy way to address them in a manner that is appropriate to meet the functional and prescriptive requirements of the building regs. The guidelines are designed to work holistically through all parts of the building regulations, that they do take into account that there are other parts that need to be met, that they work together seamlessly with other publications, not only the TGDs, but also documents like the ACDs. They are proven build-ups in terms of the fire resistance tests for the supplementary guidance in accredited laboratories, meeting the performance requirements of the building regulations. Other build-ups, other details can be used, but they have to be proven by test, meeting the equivalent performance. They have to be reflective of the end use. They have to be using proper materials to be fit for purpose. In order to deliver the objectives of the Building Control Act, that is, buildings that are safe and fit for purpose for the users. Thank you very much.